All right, so this is what we ended up with, or rather, I should say, I ended up kicking off our render. I didn't actually say you should do it. This is what I ended up with because I had some extra time between recording these chunks of the lessons. So there it is. This is the latest and greatest. We're going to see our wet maps for the first time, which look really cool. They help to integrate it into the sides here, or I should say, the first time we're going to see them animated anyway. We also have our whitewater, as you can see. It starts with this nice thin foam here, which is actually a product of the shader. Remember, on the shader, we have the vorticity to diffuse. And then it kind of just turns into the foam, which is the whole separate process. And, the foam kind of has some shape to it, from the gradient stuff we just talked about. So it's looking pretty cool. I know I said we're going to do the sprays next, and we will, generally speaking. But there is a few things, just a few little housekeeping things we should talk about first. One is, if you haven't, I'm sure I put the annotation in by now, but essentially in the wet map cache, I mislabeled it. I called it whitewater dynamic because, oops, I forgot to change it when we copied it. Not a big deal. I'm going to keep it that way because I don't, if I change the name of it, then that means that where it looks for the cache is going to change, and I don't feel like fixing that. So maybe I'll change that for when we do the high-res stuff. That's the first order of business. Second order of business is sometimes you'll get these kind of bright spots like here. This is not from the whitewater, obviously, and nor is it actually from the surface of the water. This is being caused by air bubbles, more or less air bubbles, being trapped on some of the collision stuff below the surface. There's probably actually more of it than this, but a lot of it's being covered up by the density of the interior volume. So all that is to say, let's take a look at it geometrically, what's happening there. So there's a rock apparently directly below this big rock that's doing it. So if we're back here, I'm going to turn on the liquid itself, and I'm going to turn on the well, we know it's the rocks, so that should be enough. So looking right around here, I'm going to dive under the water, so to speak. Oh, I missed it. There we go. So what you get is this look where you have things like this. What are we seeing? This dark area is all the liquid itself. It's the mesh of the liquid. And the rocks are the light one. So why do we get this patchiness? Well, it's because it's a little imprecise in terms of where the liquid mesh lines up, where it rests on the mesh. There's a couple ways of fixing this. I find that one of the maybe more intuitive ways of understanding what this is just to simply push the mesh into the rock. The mesh can only ever really be a particle separation away, or the voxel size away. So we can say use a ray to look at the normals of all the points in the liquid mesh and just try to go that direction. If you hit a rock within that small gap, then push into it. Everything else, if you don't hit a rock, then don't move at all and just stay where you always were. So coming into liquid cache, if we look at the original particle fluid sim here, it should be the same as our cache version. And there you go. So it's the same. So I need to say, because we need to basically recache this. We can't do this, what I'm about to do with the ray, we can't do it after here, because this is a pack disk primitive. It can't be modified anymore. So from here, we'll say do a ray, and we'll ray you to all the collider stuff. So I'll say ray us to the polygon stuff, because that's what's causing the issue, is that the exact polygon ones, when this got turned into a volume for the simulation and then sampled again, we lose some of the actual fidelity of it. So clicking on this right off the bat, it kind of just blows up because stuff is shooting all the way across. There's no limit to how far it can move right now. So let me turn this off again to find where I was. Sorry about that. Okay, so I should expect this one to get fixed. This is probably the actual one that's causing the issue on here. So it's a good enough test as any. So turning this on blows it up. Like I said, we want to limit the distance though, that it can't just move these things all the time. So I'm going to say use the particle separation, put it here, and we can just give it a little bit more room to breathe. Let's see, anything coming from that? So we are still seeing out here, that's why that was messed up. We were still seeing the old final liquid there. So let me show objects again. Okay, good. So now you can see it pushes it to the surface, but only in those spots. If you look at the surface of the liquid, generally speaking, it doesn't move because those things didn't find anything within this max distance. Now, once it gets to the surface, we should just give it a little bit of help. That just means if you hit the surface, go this much farther. As you saw, it is resting right along the surface right there. So let's just give it a little extra kick over. So now we should have pretty clean surfaces. These gaps will still be a little less than ideal, but most likely they're not what's causing our issue. It's these big ones. So that's pretty much it. At your leisure, or I guess it's now really, cache this again. Just do it right here. Don't bother with the whole rigmarole out there. So let's just cache that, and then we can continue rendering with, hopefully we won't see those white patches anymore.